Next topic is Fermat's little theorem. This theorem says for two numbers, a is any number and p is prime number, the GCD between them is 1. That means both are relatively prime to each other. Then a power p minus 1 is divisible by p. That is a power p minus 1 congruent to 1 mod p. Let's see the first problem. Show that a power 30 minus 1 is divisible by 31. Here they have not mentioned solve using by Fermat's little theorem. By looking at this, you should be able to identify that this we have to solve by using Fermat's little theorem. Okay, so here a is equal to 8. So if we compare this equation, we'll get a is equal to 8, p is equal to, they have given 31, which is a prime number, Now GCD of these two must be 1 according to this theorem. Okay, according to this theorem, GCD of these two numbers must be 1. Let's check that out. So factors of 8 are 1, 2, 4, 8. Factors of 31 are 1 and 31. So common factor is 1. This is only highest. So we'll get what? GCD as 1. So GCD of 8, 31 is equal to 1. Now, so by using Fermat's little theorem, which is this formula, a power p minus 1 congruent 1 mod p. Or if you send this 1 on the left hand side, we can write that as a power p minus 1 congruent to 0 mod p. P value is 31, 8, a value is 8, 8 power 31 minus 1 congruent to 0 mod p value is 31. Therefore, finally you can write what? 8 power 30 minus 1 congruent to 0 mod 31. Why we brought that minus 1 to the left hand side? Because in the question they were asking the same. Show that 8 power 30 minus 1, 8 power 30 minus 1 is divisible by 31. When do we say divisible? It is if it is completely divisible. The remainder is 0. The remainder is 0. We have got the remainder as 0. Therefore, 8 power 30 minus 1 is divisible by 31. Okay, that is their solution. Then second category of problem, we have find the remainder when 72 power 1001 is divisible by 31. So for these kind of complicated problems, we can make use of Fermat's little theorem. So how do we make use of that? Let's see. Let us write the first p value. P is equal to 31. Okay, prime, which is a prime number, and they have given 72 as a value. Right, 72 is congruent to, let us write like this. Okay, 70, we have written p value as 31 first part. Second part, 72 is congruent to what mod they have given? Mod 31. Okay, when you divide 72 by 31, 31 2s are 62, remainder is how much? 10. This remainder I can write here. Okay, this remainder. So the congruence is true. That is what we have written. Consider 72 congruent 10 mod 31. Now I want 72 to the power 101. So powering both sides by 101, 1001. So 1001 here, 1001 here. Now since this is a large number, we will make use of Fermat's little theorem. How? By taking this separately, 10 to the power 1001 mod 31 separately. A value we will take as 10. Okay, then a comma p we can find out, that is 10 31. GCD will be 1. Okay, By Fermat's little theorem, a power p minus 1. P is how much? 31. 31 minus 1, 30. So 10 power 30 we have written. These all as it is. 1 mod p value is 31. 1 mod 31 as it is. Now still I want how many? 1001. So 30, 10 power 30 already we have. Whole to the power 33 on both sides. 10 to the power 30 whole to the power 33 congruent to 1 power 33 mod 31. So in the next step we'll get 10 to the power 990 congruent to 1 mod 31. So we have got 10 power 990 as congruent 1 mod 31. Still we need 10 power 11 more. 10 power 990 into 10 power 11 to make this as 10 power 1001. So how we are doing that? This 10,101 can be written as 10 power 990 into this 11. This 11 we can split like this, because by smaller values, by small value of 10 square, we can substitute this 10 square as 7, and then we can substitute the value of 10 power 8 separately by calculating. So first we will take 10 value will be as it is, then we'll come to this value 10 square, which is 100. Okay, that is when you divide 100 by 31, okay, you'll get the remainder as 7. So that is what we have written here. So the congruence is true. 10 square value you can substitute it as 7. Then 10 square you have got. So 10 square whole square can be done. Okay, 7 square will get here on the right hand side. 10 power 4 congruent to 7 square is 49. So 49 minus 31 will give us minus 13. Okay, 10 power 4 as it is. Then 10 power 4 we have got as minus 13 mod 31. So squaring on both sides. Why we are squaring? We need 10 power 8 value. So 10 power 4 whole square will give us 10 power 8. So minus 13 whole square will give us 169 mod 31. 10 power 8 can be written as mod congruent to 1431. How do you reduce this again? Substitute or take 169 here, 31 here, the remainder will be 14. That remainder is written here. So finally using, so here we have written using 1, we can write what? 72 to the power 1001 can be written as 10 power 990 into 10 power 8 into 10 square into 10 mod 31. So this value is 1. This value we have got as 14. This value we have got as 7. This value as it is mod 31. So we'll get 14 into 70. Okay, 14 into 70, and here it's been reduced again. It's been reduced. 70 has been reduced to 8. So we can get 112 mod 31. 112 is again reduced to 19. Now again same thing. 31, you'll get remainder as 19, that you substitute here. Therefore 19 is the remainder. Let's check out the third problem. Show that 2 power 340 congruent to 1 mod 31 by Fermat's little theorem. Okay, p value is 31, a value they have given 2. Fermat little theorem says a power p minus 1 congruent to 1 mod p. A value is 2, 2 power 31 minus 1 congruent to 1 mod p value is 31. Here we get 2 power 30 congruent to 1 mod 31. Now how much we need? We need 2 power 340. 2 power 340. So 2 power 30 we already have, whole to the power 11. 1 to the power 11 on the right hand side. So we'll get 2 power 330 on the left hand side. Congruent to 1 to the power 11 is 1 mod 31. Call this as equation number 1. Then you have what? Still you want 10. So we have got 3 2 power 330. We need 2 power 340. So 2 power 10 extra we want here. 2 power 10 we want extra. So what do we do that? How do we do that? We will split that like this. 2 power 5 we will find out first. 2 power 5 will give us 1 mod 31. Okay, this is true. You can check, you'll get the remainder as 1. Then 2 power 5 whole square can be done. Okay, to get 2 power 10 value, 2 power 10, which is also 1 mod 31. Therefore, so using 1, we get 2 power 330 here. 2 power 330 into 2 power 10 will give us 3 power 2 power 340, which is the value congruent to 1 mod 31. And the final equation, final question, try to solve on your own. Try to solve these equations, try to solve these problems on your own.